Solar engineers compare different solar panels and calculate how many solar panels fit on a roof in different orientations. We will be looking at different designs of rooftop solar to calculate their electrical output and determine which design produces the most electricity. Solar panels come in many different sizes. Some are small enough to use in classrooms for different experiments, while others are very large for the roofs of different buildings or homes. The larger the solar panel, the more electricity it can produce. The electrical output of a solar panel is measured in watts. The higher the wattage of a panel, the more electricity it produces under ideal conditions. Here we have three different solar panels, all of different sizes and wattages. The panel on the left is the smallest and has an output of 150 watts. The middle panel is the largest and produces the most electricity at 250 watts. And the last panel on the right produces 200 watts of electricity. Now let's go through some of the math to determine system size, meaning how much electricity can be produced by the entire solar rooftop system. The table shows how if we had a roof with 25, 55, or even 250 panels, we would be producing different amounts of electricity. Note that the panels have different power outputs, meaning that some produce more electricity than others. If solar engineers were given this sample roof to design a solar system, they would have to take certain considerations into account. The orientation of the solar panels can determine the number of panels that can fit on a roof. The pictures here show portrait and landscape-oriented solar panels. Depending on the orientation of the panels on the roof, more or less panels can fit, therefore affecting how much electricity the entire roof system generates. Here we have a model rooftop with all the panels in portrait position. Here we have the same rooftop, but now the panels are in landscape position. Now we are going to walk through an example problem of how we can calculate the output of a roof solar system and compare panels to find optimum electrical production. Here we have our model solar panel with its specific dimensions measured in inches. This will be the building we will be working on for this problem. These are the dimensions of our building. They are measured in feet. However, since our solar panel dimensions are measured in inches, we have to convert our units first before continuing on. First, we will be calculating how many of our solar panels would fit on this rooftop if they were installed in landscape position. Always remember, we cannot have half a solar panel, so we must always round our answers down to the nearest whole number. After doing our calculations, we find that 6 panels fit the length of our roof and 4 panels fit the width of our roof when the solar panel is in landscape position. After doing the math, we determined that 24 of our solar panels fit in landscape on our roof. Now we will figure out how many of these solar panels fit in portrait position on the roof. After doing our calculations, we find that 11 panels fit the length of our roof and 2 panels fit the width of our roof when the solar panel is in portrait. Again, remember, we always have to round down to the nearest whole number since we can't have a fraction of a solar panel. We determined that 22 of our solar panels fit on this roof in portrait position. Now that we have figured out that 24 panels fit on the roof in landscape and 22 panels fit in portrait, we have to determine what would be the power output of the entire roof if we were to actually install these panels. How much electricity would our roof system make with our 22 panels in portrait? And how much would it make with our 24 panels in landscape? Our solar panel has this power output of 200 watts. We multiplied that wattage by how many panels fit on the roof in both landscape and portrait. Then we convert our units from watts to kilowatts. Which solar system design, portrait or landscape, would produce the most electricity? So as a solar engineer or solar installer, which orientation would be best to install our solar panels on this roof?